At 6:43 a.m. on September 14, 2024, construction engineer David Hartman knelt in the mud beneath what used to be Block 17 of Stalag Luft 6, staring at a timber beam that shouldn't exist. The beam was oak, hand-hewn, perfectly preserved in the clay soil of Heidekrug, Lithuania. It ran perpendicular to the foundation trench his crew had been digging for a new museum wing. Hartman was 52, had worked construction for 28 years, had excavated dozens of historical sites across Eastern Europe. He recognized immediately what he was looking at. This wasn't foundation debris. This was engineered structure. This was a tunnel. And according to every engineering assessment conducted since 1944, this tunnel was impossible. The German engineers who built Stalag Luft 6 in 1943 had chosen the location specifically because the soil made tunneling impossible. The camp sat on a layer of dense clay, 40 feet thick, beneath which lay waterlogged sand that collapsed instantly when disturbed. The water table stood just 12 feet below the surface. Any tunnel dug deeper than 8 feet would flood. Any tunnel wider than 18 inches would collapse. The Germans knew this. They had tested it. They had built the camp on geology that defeated engineering. The prisoners knew it too. Or they should have. Hartman called the site supervisor. Within an hour, ground-penetrating radar confirmed what the timber beam suggested. The tunnel ran 247 feet from Block 17 to a drainage culvert beyond the camp's eastern fence. It maintained a depth of exactly 11 feet, just above the water table. The cross-section measured 24 inches by 24 inches, large enough for a man to crawl through. The walls were shored with timber every 3 feet. The roof was reinforced with boards salvaged from bed frames. Air ventilation used a pump system built from empty food cans and leather bellows. The tunnel had been backfilled deliberately after use, which explained why German security sweeps never found it. And it had been constructed in 97 days during the winter of 1943, when the ground was frozen and the clay was hardest. This shouldn't have worked. The engineering was impossible. But 127 men had crawled through this tunnel between January and March of 1944. 17 of them made it to neutral Sweden. The rest were recaptured, but none died during the escape attempt itself. 0 casualties during an engineering project that violated every principle of soil mechanics, structural integrity, and common sense. The story of how they did it starts with Flight Lieutenant Thomas Calloway, 28 years old, shot down over Bremen in August 1943. Before the war, Calloway had been a civil engineer in Manchester, had worked on the Liverpool to Leeds railway tunnel project. He understood soil mechanics. He understood the mathematics of load-bearing timber structures. When he arrived at Stalag Luft 6 in October 1943, he spent his first week studying the camp's foundations, watching how water drained after rain, observing which buildings had settled and which hadn't. His conclusion matched the German engineers' assessment. Tunneling was impossible. The soil wouldn't support it. Calloway told the escape committee as much. The committee chairman was squadron leader James Fletcher, 34, shot down over Hamburg in July. Fletcher had already surveyed possible escape routes. The fence was electrified and watched by towers every 100 yards. The forest beyond the camp was patrolled by dogs. The nearest railway station was 40 miles away. Swimming the Baltic was suicide in winter. That left tunneling. Fletcher asked Calloway if there was any way, any engineering solution, any technique that might work. Calloway said no. The water table was too high. The clay was too unstable. Any tunnel would collapse or flood within days of breaking ground. Fletcher asked him to try anyway. Calloway spent the next 3 weeks developing a plan that violated every engineering principle he'd learned. Standard tunnel construction required vertical shafts for access and ventilation. The Germans watched for vertical digging. Calloway's design used a horizontal entrance through the floor of Block 17's latrine pit, disguised as routine waste excavation. Standard shoring required heavy timber, every 18 inches to support clay soil. Calloway's design used lighter wood every 3 feet, compensating with a compression arch technique that distributed load across the timber frame instead of the soil. Standard ventilation required multiple shafts to circulate air. Calloway's design used a single tube made from empty Red Cross parcel tins, powered by a hand-cranked bellows system that pushed air 247 feet through a 2-inch pipe. The design was insane. Calloway knew it, Fletcher knew it, but they also knew that conventional escape attempts had a 3% success rate. If this tunnel collapsed and killed everyone inside, that was still better odds than most escape plans offered. They started digging on November 8, 1943. The entrance shaft was 8 feet deep, lined with boards from bunk beds, accessed through a false floor panel in the latrine. The Germans inspected latrines weekly, but never dug into the waste pit itself. The smell kept them away. The prisoners used that. They positioned the entrance directly beneath the pit's deepest section, where the stench was worst. German guards stood 6 feet away during inspections and never noticed. The tunnel crew worked in 4-hour shifts, 2 men digging, 1 hauling soil, 1 operating the air pump. The clay came out in chunks. They couldn't scatter it on the surface. The Germans watched for fresh dirt. Instead, they hid it beneath the latrine's waste pit, mixing it with sewage until the color matched. Disgusting work. Nobody volunteered. Fletcher assigned rotations. Every prisoner in Block 17 took a turn. The first week, they advanced 8 feet. The clay was dense, required picks to loosen. The timber shoring took 3 times longer to install than the digging itself. Each frame had to be fitted precisely, wedged tight against the walls with wooden shims, tested to ensure it wouldn't shift under load. 1 loose frame meant the entire section could collapse. They had no margin for error. By week 2, they'd advanced 21 feet. The air pump was working, barely. The tin pipe leaked at every joint, required constant repair. The bellows operator had to crank continuously to maintain airflow. Men rotated every 30 minutes because the work was exhausting. At 40 feet, they hit their first crisis. Water began seeping through the floor. Not flooding, just steady seepage that pooled in the lowest section. Calloway had anticipated this. He'd designed a slope gradient of 1 inch per 10 feet, just enough to drain water back toward the entrance shaft where it could be bucketed out. It worked, but it meant the tunnel was now angled upward, climbing gradually toward the fence line. The math was tricky. Too steep and they'd surface inside the fence. Too shallow and they'd never clear the fence line before hitting the water table. Calloway recalculated nightly, adjusting the dig angle based on how far they'd advanced. He had no surveying equipment, just a makeshift level built from a glass tube filled with water and a wooden protractor. The measurements had to be perfect. They were. By December, they'd reached 90 feet. The tunnel had taken on a rhythm. Dig, shore, haul, dig, shore, haul, dig, shore, haul. The repetition was meditative. Men stopped talking during shifts. The work required concentration. 1 mistake, 1 timber placed wrong, 1 shim forgotten, and the whole structure could fail. They'd been lucky so far. The clay was holding. The shoring was stable. The ventilation worked. But everyone knew the real test would come when they passed beneath the fence line. That's where the German engineers had predicted collapse. They reached the fence line on December 22nd, 107 feet from the entrance. Christmas was 3 days away. The Germans had increased guard patrols for the holiday. Fletcher wanted to halt digging until after New Year. Calloway disagreed. The ground was frozen solid. That made the clay more stable, less likely to collapse. Winter was their best chance. They kept digging. On January 9, 1944, they broke 200 feet. The air pump was struggling. The distance was too far. They needed more pressure. Calloway redesigned the bellows, increased the piston diameter by 40%, installed a longer crank arm for leverage. It helped barely. The man at the face could breathe, but he couldn't work more than 20 minutes before exhaustion set in. They rotated diggers every 15 minutes. Progress slowed to 3 feet per day. On February 3rd, they hit 247 feet. Calloway calculated they were 15 feet beyond the fence line, far enough to clear the patrol path. They started digging the exit shaft, vertical, straight up. This was the most dangerous part. If they surfaced inside the security zone, the guards would see them immediately. If they miscalculated the distance, they'd surface short of the drainage culvert and expose the tunnel. Calloway had designed the exit to emerge inside a concrete culvert that carried runoff from the camp toward the forest. The culvert was 4 feet in diameter, ran 200 yards to the tree line. If they surfaced inside it, they'd be concealed from guards and could crawl directly to cover. They dug upward for 6 days. The exit shaft climbed 11 feet through frozen clay. On February 9th at 11:47 p.m., the lead digger's pick broke through into empty air. He was inside the culvert. The geometry had worked. Calloway's calculations had been perfect. The escape began on February 11, 1944. They scheduled it for 2 a.m., when guard patrols were lightest. 127 men would attempt the crossing. Not everyone would make it, but everyone would try. The tunnel could handle 1 man every 6 minutes. That meant the operation would take 12 hours. Dawn came at 6:30. They'd have to close the tunnel and hide in the forest before daylight. The first man entered at 2:08 a.m. He crawled 247 feet in 18 minutes. The second man followed at 2:14. By 3 a.m., 11 men were through. By 4 a.m., 29. The tunnel held. No collapses, no flooding, no structural failures. At 5:30 a.m., prisoner number 87 got stuck halfway through. His coat caught on a timber shim. He couldn't move forward or backward. The men behind him were trapped. The man in front couldn't help without crawling backward, which would delay everyone. Fletcher made the decision. They'd have to widen the tunnel at that point, just enough to free the coat. It took 14 minutes. Precious time lost. At 6:17 a.m., the first guard patrol noticed the unusual number of men missing from morning roll call. By 6:30, they'd discovered the entrance shaft. By 6:45, they'd sealed both ends. 112 men had escaped through the tunnel. 15 were still inside when the Germans sealed it. They were pulled back to the entrance, arrested immediately. The 11-12 who escaped scattered into the forest. German search parties deployed within an hour. They had dogs, trucks, local police assistance. Over the next 3 days, they recaptured 95 men. 17 made it to neutral Sweden by train, on foot, and in one case by stealing a German supply truck and driving it 400 miles to the Swedish border. Not a single prisoner died during the escape attempt. The tunnel never collapsed. The engineering that was supposed to be impossible worked perfectly. The Germans couldn't understand how. They brought in engineering teams to survey the tunnel. The reports are preserved in Soviet archives. Every German engineer who examined the structure concluded the same thing. This shouldn't exist. The clay should have collapsed. The water table should have flooded it. The ventilation system shouldn't have worked. But it did. All of it did. Calloway was among the 95 recaptured. He spent 6 weeks in solitary confinement, then was transferred to Stalag Luft III. He survived the war, returned to Manchester, resumed his engineering career. He never spoke publicly about the tunnel. Neither did most of the men who built it. The official German records listed the tunnel as structurally impossible and attributed the escape's success to luck. Post-war historians assumed the Germans had exaggerated the engineering challenges. The clay couldn't have been that unstable. The water table couldn't have been that high. Someone must have made mistakes in the original assessment. No one had. The soil was exactly as difficult as the Germans claimed. The tunnel should have failed. It didn't because Calloway had done something no engineering textbook recommended. He'd designed a structure that worked with the soil instead of against it. The compression arch shoring distributed weight across the frame instead of pushing it into the clay. The shallow angle kept them just above the water table without requiring deeper digging. The slow, methodical construction gave each section time to settle before adding the next frame. The techniques were unconventional, but they worked because Calloway understood that sometimes the rules exist to be rewritten. The tunnel remained buried and forgotten for 80 years. The camp was demolished after the war. The Soviets built a factory on the site in the 1950s. The factory closed in The land sat vacant until 2019, when the Lithuanian government approved construction of a memorial museum. Hartmann's crew broke ground in September 2024, and at 6:43 a.m. on September 14th, they found an oak beam that shouldn't exist. Within 3 months, archaeologists had excavated 180 feet of the tunnel. The timber frames were intact. The compression arch design was visible. The ventilation pipe was still in place. Tin cans soldered together with lead stripped from the camp's electrical wiring. Every detail confirmed what the historical records had denied. This tunnel was real. This tunnel was impossible. This tunnel worked. The museum opened in March 2025. The tunnel is the centerpiece. Visitors can see the entrance shaft, walk alongside a glass-enclosed section of the original structure, touch the timber frames that 127 men crawled past on their way to freedom. The engineering is explained in detail: how the compression arch worked, how the ventilation system functioned, how men with no heavy equipment and minimal materials built something professional engineers said couldn't exist. Calloway died in 1989. He never knew his tunnel would be found. Neither did Fletcher, who died in 1973. Of the 127 men who crawled through that impossible tunnel, only 3 were still alive when Hartman's crew discovered it. One of them, David Chen, 102 years old, flew from Sydney to Hajduk for the museum opening. He stood at the entrance shaft, looked down into the preserved section, and told reporters the same thing he'd told his family for 80 years. "We didn't think about whether it was impossible. We thought about whether it was necessary, and it was." If this story moved you, please like and subscribe. Tell us in the comments where you're watching from.